My name is Lejane and I did prompt 1 and I chose single dominant epistasis to explain it. So what epistasis really is when two loci contribute to the same phenotype. So when we're looking at traits, we often think that one genotype is specific to one phenotype, when in reality, a trait is determined by the interactions of genes products from more than one locus, meaning that the gene is associated with locus A will produce a product inhibitor B that will prevent us from going down this cascading effect to get to a final phenotype. And so in single dominant epistasis, the expression of dominant allele A at locus A can mask the alleles of locus B. So we get this inhibitor and we no longer care about what happens at locus B. Or we can not have this inhibitor, we can have a homozygous A alleles, and then we can go boom, boom. But then if we have also a homozygous B, we could stay at a pink intermediate. So in other words, there could be multiple genotypes that lead to the same phenotype of colorless pink or gray. So when we're looking at the dihybrid crosses, and we look at a heterozygous, it no longer follows Mendel's 9 to 3 to 3 1 ratio, because that is not an example of a stasis. Instead, every single time we have a dominant A allele, it is going to produce a white colored dolphin because we have this inhibitor A that keeps us from going down this pathway. It just prevents it right here. But let's say we don't have it. Let's say we were looking at the genotype of homozygous AAA locus A, and then we have a dominant A or dominant B allele right here. Then we would go boom, and then we could, if we have the dominant B, get to the gray. But if we do not have it, we have a recessive B allele, like right here, then we could stay at the pink intermediate, and you can kind of see them with the colors. So the phenotypic single dominant epistasis ratio would be 12 to 3 to 1. And then if we look at something that wasn't heterozygous to begin with to cross, it wouldn't even follow Mendel's 9 to 3 to 3 1. So we could no longer add these like things to get whatever our phenotype is. So we can kind of break it down a little bit more. Every single time we're going to have this dominant A allele, it is going to inhibit us and we're going to stay at the white. But then if we have we have a recessive A allele, we're going to produce enzyme 1 and 2 and get to the gray. So we'll go boom, boom, and then we'll get to the gray. But if it's all recessive genotypes of alleles at both locus A and B, then we're going to produce enzyme 1, but not enzyme 2. Thank you.